Hello there guys, here I'm going to try to explain the concepts of multidimensional arrays. I'm going to begin by introducing myself. I'm Saniya and I took the CS 200, 300 and 400 series at University of Wisconsin, Madison. And one of my best friends throughout the whole entire process was Java Visualizer. So here I'm going to show you that using Java Visualizer, you can basically write for anything that you're interested in, like for string arrays. What you can do is that this is, for example, a sample string array object. It's a string object. So here I have mentioned that I want it to hold 5 elements. So it's a string that can hold 5 elements, and then the first element, so it's indexed at 0, is Saniya. The next one is loves, which is indexed at 1. Then the third one is indexed at sample string array 2, Java, and then visualizer, and then the smiley. So if you want to visualize arrays, and I think that's as complex as you can visualize as of now, you have to click under options, show string, integer, etc. objects, not just values. So here we're going to visualize what does it look like exactly. So you can see here that we are creating so sample string array is on the stack, and it's referencing on the heap, which is under objects. It's referencing a one-dimensional array that can hold 5 objects, so 0, 1, 2, 3, and 4. So as we are going through, because a string, capital S, is an object, each of these will be referencing an object. So this sample string array at 0 it references Saniya, which will be another object on the heap. Similarly with loves, and then with Java as well. You can see that we're creating new and new objects. So now I'm going to talk about some of the concepts here. So this is from CS200, but it's a lab on multidimensional arrays. So what I was, okay, so this is, our initial situation is the following. We're asked to trace and explain this over here. So we have a char that is called str array, and what it's doing is it is equal to a new char, and then that is equal to this new char. We have initialized it with x 0 0 0 x and empty space x 0 x. So how does this look exactly? So how this looks in memory is like this, the following. We have str, which is a reference variable. This is on the stack, and then it is referencing this object that is on the heap. And this is on the heap over here. This whole thing is on the heap. And so str arr is referencing a 1D array object, and each of these elements is referencing its own 1D array, and we've initialized it in one step. So this is kind of how it looks. Let me show you. So what happens is that this over here, what I'm pointing to with my arrow, this is strarr0. And this is all on the heap over here. This whole thing is the heap. Oh wait, sorry about that. This whole thing here is the heap. Okay, and what we notice here is that we have these brackets, and within these brackets we have assigned this x 0 0 to this first over here. This is how it maps. The 0x and an empty space maps over here to this next one, and then this last one here, we can see between this it maps, so it's between these two brackets, and it is explaining what this last x 0x is. So in one step, what we have done is we have said that we have a 2D array, and this 2D array is made up of 3 1D arrays, because we have 3 of these brackets here, 3 of these. 1, So you can have 3 of these brackets here. So 3 of these colors. So we're saying that we have 3 of these arrays, and then inside each of these arrays, we are assigning those elements all in one step. So that's what happens. So each of these arrays is separated by a parenthesis bracket, one of these brackets. Another way we could do this, there's always multiple ways to get the same thing, but another way we could do this is by saying char str array equals new char 3. And when we're doing that, we are saying that str, so it's on the stack and it's pointing to the array over here, which is STARR 0, 1, and 2. And then what we could do is we could manually go and then update each of these STAR 0 to equal X0, 0. So it's a game of tic-tac. STAR 1 to equal this, and the second one to equal that. So pretty much this is how it looks in Visualizer, and then just to show that you can do the same in Visualizer to see it. So basically, STARR is a 2D char array that is made up of 3 of those one-dimensional char arrays. And to access any element inside that 2D array, we need to use double brackets. So it's a 1D array element that we want to look into. So pretty much we have this over here. When we first create it, the values are null because these STAR is pointing on the heap to, this is on the stack, which is in blue, and it's pointing on the heap to a 1D array. And an array's default values are all null, so these are by default null. And then we're going through, and in each step, so we've said there are 3 elements, and we always have to specify at least one of these brackets, unless we initialize them in one spot, which we've done here. We initialize them all in one place. Unless we do that, we have to then otherwise just mention that we have 3 of these 1D arrays, and then that it will tell basically Visualizer that this is the state of affairs. And Java as well, that this is how it needs to look. It needs to str has to reference 1D arrays, a 1D array that holds 3 elements inside it. So as we're going through and we're adding each of these, then we can see how this 0 to X0, 0, and how the first one is also filling up to 0x empty space, and how the third one is X0x, and how they are pointing to these. And because it's a char, it's a primitive, these arrays will actually hold these values inside of them. So similarly, we can see that we have double nums of 8, 0, 9.5, and 10.1. And this, because it's a lowercase d double, it is a primitive type, and therefore these are just values and not objects. So we could initialize it in one stroke as we did over here, or we could break it apart in the following. We could just say, but we have to specify that we will have 3 of these elements in the double. We could say that double, we have nums, which is a double lowercase d, and it holds these as primitive values, and nums 0 is 8, nums 1 is 9.5, and nums 2 is 10.1. So this is how it would look. Nums is pointing, it's a 1D array, and frame is the stack, and the objects are found on the heap. So 8, 9.5, and 10.1. So now what we have is, we now see that instead we want to come up with a 2D array which is called table here. And what we want to do now is, what we see here is we have these double brackets. Here, as we need here, we have double brackets. And then each of these inside is within a set of brackets. And this is within a set of brackets. And then this purple is within a set of brackets. So these are the signs of a 2D array, and we've initialized everything in place. So it has table 0, table 1, and table 2. And each of those points to a 1D array and holds a reference address for a 1D array. So this pink is table 0. This is pink. This is what table 0 is. It's this pink. And then table 1 is this in red, which is this. And the last one is what is table 2. So that because it's the lowercase double, each of these is still a value. And these are the corresponding sets of values here: 1, 2, 3, 4, 5, 6, 7, 8, and 9. And this is how it looks in memory. But now they will be found in the arrays. So the lowercase d double, it's primitive, and the default values are 0. Before we initialize it, the default is 0 because it's a primitive double. But so this is a primitive double here. But if we use capital D double instead, so here we used a lowercase d double. So if instead we use a capital D double, it will be an object and the default values will be null. So now let's say that instead we are doing double, capital D double. And not only that, but let's say that we change, so this is 1, 2, 3, and it was supposed to be 4, 5, 6, 7, 8, 9. But let's say that this 3 is instead of the original 4. So this would have been a 4, but let's just say we changed it to a 3. Now this is D double, so this is an object. So this array is holding a reference for an object. So what we see here is that this part here, which is like circled, this is the same as before. A table is on the stack and it's referencing a 1D array over here. And now what we see is that this 1D array is the same as before, and what we would have wanted is that before, what would have been the case is that this would have been a 1, 2, and 3, and then we're done. That's what happened before. The 0 was pointing to this array, which was 1, 2, and 3. 1 second. Then we were done. We just had them pointing to those values. And same with this array over here. It was pointing to those values as well. 4, 5, 6. And then this over here was 7, 8. So this over here was just a 7, 8, 9 value. And then we were done. See, just as a little refresher, you can just see over here how each of these was pointing to, a set of those values as 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we were done. But now what happens is because we have a double object, then what we're going to have to do is we're going to change things a bit. We see that we're still pointing, but instead of holding 1, like this element here will instead point. It's going to point instead to this 1 because this 1 is an object. So this array, everything is the same. This is still pointing to the same 1D array over here, but the main change is that instead this is still the same, but now instead of holding those values, it is pointing to a 1. And this is pointing to a 2 instead of holding it, and this is pointing to a 3 object because this 3 is a capital D double. And what you will notice is that with this new thing, it is 1, 2, 3, 3, 5, 6. So so we have an object that's a 3 and another object that's a 3 over here. So I designed it to show you that even though we have both 3s, even though this points this 3 is over here, and this is also a 3. What will happen is that this points to its 3 over here, but that there's another 3 object here too. They're both separate instances. So this is how it looks in memory, that each of these still points to the same arrays as before, but instead of holding those values, these point to these other values on the heap. So each of these elements in the array is a new double object. So anytime you have a double, it's not going to be contained in the array. It'll be pointed to, because now the array inside it, instead of holding it, it's a reference to the object. So we point to them. So even though the both table 0 and table 1 both have 3 in them, they still point to different 3 objects, their own 3 objects. So that's very important to know. And then lastly, I kind of want to talk about how does it, so char, the beauty is that you can really access the elements inside a char. So here we have char letters is equal to new char, so it's a 2D array. And what we see here is we have the elements, we have these double brackets here, and then we see that what's inside these single brackets is one array, and what's inside this is another array. So we have this purple, which is AB, which is the first one, which is letters of, so this is letters of 0, And then we also have the second element, which is CD, which is the second. So that's what letters 1 points to. So basically, what letters does is it points to an array. So how to think about this is that letters basically points. So when you think about letters, you can think of it as kind of pointing to letters 0 and then letters 1. So it's pointing to this on the stack. It's pointing to actually this. And then each of these, this will be pointing to an array with this, and then this will be pointing to an array with this. But letters is actually pointing to letters 0 and letters 1. And each of these is then containing their own objects inside them. So I'll explain that as we go down. It's because what you can think about here is that pretty much letters is pointing to, this is letters of 0, and this is letters of 1. That's what it's pointing to. And then letters of 0 is pointing to our AB. So letters of 0 is pointing to our AB over here. And then our letters of 1 is pointing to this. So the way that you can think about what's going on is pretty much it's a char array, so we can print it out directly and we can get its contents, and that's important because a char array is the only type of array that we can print out directly. Others, you have to be a bit careful when you're printing those out. So here we have a 2D char array called letters. So it has two elements, two reference variable objects that each have their own 1D arrays. So we have letters of AB over here and then CD over here. So this, as I mentioned before, letters is basically pointing to letters of 0 and letters of 1, and then each of these is basically pointing to its own AB, and this is CD. So now we're trying to print out, like we want to see what happens when we try to print out these elements inside. What is letters 0 and then letters 1, 1? What is that exactly?